So let's just talk about the first group of 8 that we have over on the left hand of the screen.
Okay, and that's A, uppercase A.
Okay, now point to, with the blade that you have, point to where the Z is.
Right here, this big guy.
The big guy at the top. Okay, alright.
Now that's before it's filtering. This is after filtering. You can see it's still there. It's still the maximum. Alright, so, and as we walk across, okay, now this is for the time. Now for the amplitude, what I'm going to do is we're over here. Now this is your
let's get this squared. No, I mean, say squared. Let's get this squared away. The characters that we see, the group of 8 that we see right there, okay?
On the top.
Okay, that is at 25 kilohertz.
25.
That is our characters coming out of the EEPROM before they are filtered.
Yeah, it comes out of the EEPROM and it goes into the operational amplifier where it's turned from current into voltage, and this is your resulting output. This output then is put through another low-pass filter which produces this. And this is what we're interested in right in here. Now it's all the same character.
What exactly are we interested in at the bottom? What is that bottom? What is that bottom showing us?
The bottom is showing you the voltage differential between. You see this horizontal dotted
yes.
line there? Okay, that's your reference. And here's the output from the filter. Now, as I said, they're all the same inside. These are all uppercase A's. So this distance we can measure in millivolts will then be the height of the A character, okay, cleaned up. Now as we now go on to the second one, this is a group of C's, and there's 7 of them. And obviously I did that deliberately. Again, it's surrounded before and after with Z's. Mm-hmm. All right, and as we go down and look, here's our reference point. You can see that it is slightly higher than this. Now we can actually get a value on that. This is the bottom one. We can actually measure these. For example, if we went back to the A, we can see that we have a 28 millivolt differential between the reference and the top of it, which designates the transformed A. Okay, when we go over here on this one, I'm going to move that down. Okay, we now have a 40 because it's a C. This is an A, this is a C. We now have 40 millivolts out here.
So each character
has
its own millivolt value that we are able to. So in effect, we're just showing just from the first letters, which was the capital A's, that we had the 28 millivolts. And we take it over and we take the second character, which has got a 40 millivolt. But that holds true for every single character that we have.
Absolutely.
So the effect
will have a unique voltage differential.
So the effect is that for each of the characters, and these are our characters here without the filter,
right,
we run this through our low pass filter, and what we're showing is we get this back which has been filtered through our low pass filter,
right,
and this now is able to go through the telephone line at the 3 kilohertz.
That's right.
And each one here has a different voltage level.
Unique to the character.
And that is in essence how we are able to get our characters after they have been filtered through the low pass filter.
Right. That's right. That's right.